Molten rock is hotter than a jet engine, crawling straight toward a town of 4,000 people. Not tomorrow, not next week, right now. And instead of evacuating and giving up, Iceland did something that sounds completely insane. They tried to stop a volcano with walls. Not concrete walls, not steel walls. Mountains of earth, built in real time, while the lava was already on the move. Let's get straight into it. This all unfolds near the small coastal town of Grindavík, not far from Blue Lagoon, one of Iceland's biggest tourist magnets. Beneath this peaceful fishing community sits a restless volcanic system that decided, after centuries of quiet, that it was done being polite. The ground cracked open, earthquakes rattled homes, and then the glowing rivers appeared. We're talking about lava moving at temperatures around 1,200 degrees Celsius, that's over 2,000 degrees Fahrenheit. Hot enough to melt metal, hot enough to ignite buildings just by getting close, hot enough to turn roads, pipes, and power lines into useless puddles. And it wasn't just heading toward houses. There was a massive geothermal power plant in its path, a facility supplying electricity and hot water to tens of thousands of people across the region. If that plant went down, lights out, heat off, infrastructure crippled. So Iceland faced a brutal choice: retreat or fight geology itself. They chose to fight, but you don't just pile dirt in front of lava and hope for the best. Engineers treated this like a military operation against an enemy that doesn't negotiate and doesn't stop to sleep. Before a single truck rolled out, scientists ran countless computer simulations to predict exactly how the lava would behave, where it would flow fastest, where it might pool, and where the terrain could naturally help redirect it. Survey teams walked ancient lava fields, measuring every bump, ridge, and depression. Because here's the trick: the walls don't need to stop lava completely. They just need to guide it somewhere safer. Think of it less like a dam and more like steering a freight train by nudging the tracks. Once the ideal defensive line was mapped, construction kicked off at a speed that felt almost unreal. Temporary roads were carved across rough volcanic terrain so trucks could move non-stop. Quarries were opened nearby to harvest enormous amounts of rock and soil, much of it from ancient lava flows that erupted centuries ago. Iceland was literally using yesterday's volcanoes to fight today's volcano. Then came the machines, nearly 100 of them. Bulldozers the size of small houses, excavators clawing into rock like mechanical dinosaurs. Haul trucks carrying 40 tons per load, rumbling back and forth in a continuous convoy. Imagine a traffic jam where every vehicle weighs as much as a blue whale and nobody is allowed to stop. Day and night blurred together. Floodlights turned darkness into artificial daylight. Workers rotated in shifts because the one thing this project could not afford was downtime. Lava doesn't wait for coffee breaks. Meters, 10 meters, eventually more than 20 meters in critical zones. That's taller than a 6-story building, made entirely of compacted earth and rock. Layer by layer, material was dumped, spread, and compressed. Not casually, precisely. Each layer was only about a foot thick before being compacted to near solid density. GPS systems guided machinery, so the shape matched engineering designs down to tiny tolerances. Slopes were carefully angled so the structure wouldn't collapse under the weight of molten rock pressing against it. Because lava isn't just hot, it's heavy. Imagine a glowing, slow-motion landslide made of stone. If the wall failed, it wouldn't crack politely. It would explode apart, sending liquid fire rushing through the gap. Traffic coordinators directed trucks like air traffic controllers. Bulldozers with blades wider than living rooms spread material evenly across the growing embankment. Compactors hammered everything into a dense mass. Survey teams constantly checked height and alignment. It was construction choreography on an industrial scale, and the higher the walls grew, the harder the work became. Delivering material to the top required temporary ramps that had to be extended upward as construction progressed. Operators maneuvered machines in spaces barely wider than the equipment itself, perched above steep slopes of loose rock. One wrong move could send a vehicle sliding down the side. Meanwhile, the volcano did not pause out of respect for human effort. Magma continued rising underground. Cracks widened. Tremors pulsed through the ground. It was like racing to build a levee while watching the tsunami approach. Multiple construction fronts operated at once, stretching the defensive line across kilometers of terrain. Around the power plant alone, several massive segments formed a protective arc, a shield designed to divert lava away from critical infrastructure. Once that was secured, crews shifted focus to the town itself. The planned barrier around Grindavík was enormous, a sweeping semicircle stretching many kilometers, protecting homes, businesses, roads, and especially the harbor. That harbor isn't just scenic, it's the town's economic lifeline. Fishing vessels, processing facilities, jobs, everything depends on it. Lose the harbor, and the community doesn't just relocate, it collapses. 3 separate teams advanced simultaneously from different directions, gradually enclosing the town like a giant protective embrace. Where sections met, engineers carefully interlocked the material so there would be no weak seams. It had to behave like one continuous structure. By the time major phases were complete, the scale bordered on absurdity. Millions of cubic meters of earth moved, tens of thousands of truckloads delivered, kilometers of barriers snaking across the landscape. If you laid the trucks end to end, the line would stretch farther than most people's daily commute. And then came the moment of truth. In early 2024, glowing lava began advancing toward the defenses, a slow, unstoppable wave of incandescent rock creeping across the ground. People watched from safe distances, holding their breath. This wasn't a simulation anymore. This was the test. The lava reached the wall, and instead of smashing through, it piled up. It pressed, it spread sideways. Like water hitting a dam, it began to flow along the barrier's contour, exactly as engineers had hoped. Homes behind the wall remained untouched while the molten river was guided away. In some spots, lava stacked several meters high against the barrier, forming a glowing rampart of its own. But the wall held. No breach, no catastrophic collapse. It worked. But Iceland didn't stop there. Real-world results showed where improvements were needed. Some sections were raised even higher, others reinforced. Because volcanoes don't follow scripts, each eruption teaches new lessons. Engineers also deployed an extraordinary backup strategy borrowed from history, cooling the lava with seawater. Massive pumps sprayed thousands of liters per second onto advancing flows. The water flashed into steam, sucking heat out of the molten rock and causing it to solidify faster. Instead of a liquid river, the lava became a growing crust of hardened stone. This technique had been famously used decades earlier on the island of Jaime, where residents saved their harbor during a catastrophic eruption by pumping ocean water onto the lava for months. That experience became the blueprint for modern defenses. Today's system combines both methods, physical barriers to redirect flows and cooling operations to slow them down. Add in drones with thermal cameras tracking movement in real time, seismic sensors detecting underground shifts, and constant monitoring crews ready to mobilize within minutes, and you get something that feels less like a construction project and more like a defensive network. Maintenance roads run along the tops of the barriers so teams can inspect and repair them quickly. Quality checks verify stability every few dozen meters. Even after construction, the work never truly ends. Weather erodes surfaces, the ground settles, frost cracks form. Crews patrol continuously to keep everything at peak strength. And here's the surreal part. Behind those walls, life goes on. Children attend school. Fishermen head out before dawn. Tourists soak in geothermal pools. Businesses reopen. Property values stabilize. What was once an existential threat becomes something closer to a managed risk. The barriers don't stop volcanoes from erupting. Nothing can. But they transform chaos into something humans can live with. The success has drawn attention from scientists and engineers around the world. Delegations from volcanic regions, Italy, Japan, Indonesia, Hawaii, study Iceland's approach, hoping to apply similar techniques elsewhere. While some countries have tried bombing lava flows or building concrete channels, Iceland's method focuses on rapid earth-moving and adaptive design. At the center of all this is Reykjavik, where planning, research, and coordination happen. The government treats volcanic defense as long-term infrastructure, not an emergency improvisation. Because in Iceland, eruptions aren't rare disasters, they're part of the national lifestyle. Over time, the network of barriers has expanded. New segments address newly discovered flow paths. Critical utilities are buried deeper underground. Power lines are elevated and insulated. Even roads have been rebuilt atop cooled lava, turning former danger zones into usable land. The cost of building these defenses is enormous, but the value of what they protect is far greater. Homes, businesses, ports, power plants, tourism, entire communities. In purely economic terms, the investment pays for itself many times over. In human terms, it preserves something priceless, the ability for people to stay in the place they call home. Perhaps the most impressive aspect isn't the machines or the engineering formulas. It's the human determination behind it. Hundreds of workers spent long shifts in freezing wind, volcanic ash, and darkness. Operators moving tens of tons of material with every scoop, hour after hour, knowing that if they stopped, disaster would move closer. Safety protocols were strict, and remarkably, serious injuries were minimal despite working near active eruptions. That alone is a testament to planning and discipline. 6 months of relentless construction produced what looks like a natural ridge system, except every meter of it was placed deliberately. Millions of cubic meters of rock reshaped into a protective ring around a vulnerable town. And this isn't a temporary fix. Scientists believe volcanic activity in the region could continue for decades, even centuries. These barriers are designed to endure, to be upgraded, to become permanent features of the landscape. A partnership between humanity and geology, uneasy but functional. All this isn't about defeating nature. It's about adapting to it. Humans can't shut off a volcano, but we can nudge its fury away from what matters most. So when you see photos of glowing lava stopped by a dull gray wall of earth, remember what you're really looking at. Millions of tons of material moved by thousands of hands, guided by science, built under pressure that most construction projects never experience. It's not just a wall, it's a statement that even on one of the most volcanically active pieces of land on Earth, people refuse to surrender their homes without a fight. If this blew your mind, imagine what other extreme engineering projects are happening around the world right now, from cities sinking below sea level to megastructures rising in deserts. Hit subscribe so you don't miss the next story of humans doing the impossible.